Greetings, students. Once again, welcome to another lesson from iCampSA. Today, we are doing grade 10 mathematics, and this one will be a past paper question from 2020. This paper was written in November, and it was written in Eastern Cape. Okay, without wasting any more time, let's get to the questions. Okay, this one is question 5. Okay, so the equation of the function g at x is equal to a over x plus q, a over x plus q. We are familiar with that equation. We are seeing x in the denominator there. What does that represent for us? It represents a hyperbola. That's a hyperbola. And then the value of q is our, what is this thing? Is the asymptote. It's the horizontal asymptote where our function doesn't touch or the value that our function doesn't touch. It just approaches, but it never touches. It passes through the point 4 and 2, okay, on the graph of G, and has a range of y is the element of negative infinity to positive 1 and union 1 to negative infinity. What does that tell us? Our function exists for all the values of y values except for 1. What is our 1 then? If our function doesn't exist there at 1, it means that 1 is there. It's essentially the asymptote. So y is equal to 1 is the asymptote, and the asymptote is the value of q there from our function. Okay, let's go to the question. So for 5.1, we are asked to determine the equation of g. So 5.1.1 essentially we are asked to determine the equation of g. What do we know? We already have the value of q. So q is equal to 1, and the reason is the horizontal asymptote is the horizontal asymptote. Okay, and then we have q, but we still have the value of a, which is our unknown there. We have been told that the function passes at this point 4 and 2, so we can use that point of 4 and 2. G at x is equal to a over x plus q. We can substitute the value of 4 and 2 to solve for a. It's 4 and 2. So g at 4 is 2. So we're going to have 2 is equal to a over 4 plus q. What's the value of q? Plus 1. And then let's solve for a. We take the 1 to the other side. We're going to have a over 4 is equal to 2 minus 1 will be 1. Therefore a is equal to 4. A is equal to 4, which then makes the equation of g to be g at x is equal to 4 over x plus 1. 4 over x plus 1. Okay, and then next, the equation of h, the axis of symmetry of g with a positive gradient. The axis of symmetry passes through the asymptote, so it's gonna be like this. That will be the function of the axis of symmetry, function of h. But the equation is gonna be y is equal to x plus 1. So h at x, this is 5.1.2. Therefore h at x is equal to positive gradient. We're gonna have x plus 1. That will be the equation of the axis of symmetry with the positive gradient. Okay, and then next, sketch the graph of h on the provided diagram sheet. Okay, clearly show all the asymptotes and the asymptotes and intercepts with the axis. Sketch the graph of h. The graph of h is just a straight line, so it doesn't have an asymptote. So it's just a straight line. What do we have to actually calculate here? It's just the intercepts. It's just the intercepts for 5.2, and then we're gonna go ahead and sketch the graph. So x intercepts, let y equal to 0, so 0 is equal to x plus 1, therefore x is equal to -1. X is equal to -1. Okay, and then we have y-intercept, let x equal to 0, therefore we're gonna have y is equal to 0 plus 1, y is equal to 1. That would be our y-intercept. This is a straight line equation, so we don't have any asymptotes here. Okay, once we have those 2 points, we have to go ahead and sketch. So we have -1 and 0. This one was not drawn into scale. -1 and 0. Wait a minute. For x-intercept is -1 and 0, so it's gonna be here, and the other point is basically 1 and 0 is there. It passes through the asymptote, so it's here. So the function will join the 2 points. That would be the function of h. We are asked to clearly show the intercept. We're gonna have 0 and 1, and then the one here is -1 and 0. This is the function of h. We can just say h at x is equal to x plus 1. Okay, and there you have it. Write the equations of the asymptotes of f. If f at x is equal to negative g at x plus q. Okay, so we're gonna have a negative g at x plus q. Let's first find the equations of the equation of f. First thing first. So this is 5.3. We are told that f at x is equal to negative g at x plus 3. So the function has been flipped about the x-axis and then translated 3 units upward. Okay, therefore f at x is equal to, what is the function of g at x? G at x is, we calculated the equation of g at x is 4 over x plus 1. So we're going to have negative 4 over x plus 1 plus 3. So therefore f at x is equal to negative 4 over x minus 1 plus 3 is gonna be a positive 2. And what were we asked to find here is the equations of the asymptote. So already we can see that the horizontal asymptote is gonna be y is equal to 2. So y is equal to 2. That is our horizontal asymptote. Okay, and then what's the vertical asymptote? The graph hasn't been shifted sideways, so x is equal to 0. That will be our vertical asymptote. Okay, and that is how you will go about answering that one. Okay, and then next for 5.4, use the graphs to determine the values of x for which g at x is equal to h at x. G at x is equal to h at x. The function of g is this one, the hyperbola. So these two graphs will be equal here. That is where it should be equal at about -2 and 2, so yeah, it will be about where x is g at x and h at x, -2, and where x is 2, because we have been asked to use the graph, but if we were to calculate this one, we'll just equate the two equations and then solve for x and solve for x. So for 5.4.1, okay, it's where x 5.4.1 where x is equal to, we just take -2 and 2, -2 and 2. That is where our graphs will be equal, where x is equal to -2 and x is equal to 2. Those are the two values where these functions will be equal, the function of h and the function of g. They said we must use the graphs. If we were just asked to find the values of x where these two equations are equal, we're just going to take the equation of g and the equation of h, we equate them, and then we solve. And then we are asked to find the values of x for which g at x is less or equal to h at x, where x is less than 0. So we're only considering the parts where x is less than 0, or the left parts, in other words. And then we're looking for the values of x where g at x, the function of g, is less than h at x, and the function of g will be less than h at x where h at x, where the function of g is below the function of h at x. Let's come here. From here, the function of g is above the function of what? Is above the function of h. But once we got there at -2, what happens? The function of g goes below the function of h. So from -2 to right before x is equal to 0, so 5.4.2, let's add a page. For 5.4.2, saying where x is greater or equal to -2, but x is less than 0. So let's write that in the proper way. We're gonna say where x is greater or equal to -2 but less than 0. So that is how you will present that. That is your answer there for 5.4.2. Okay. That was the last question for question 5. Next, let's go ahead and do question number 6. So for question number 6, f at x is equal to 3 to the power of x minus 1. 3 to the power of x minus 1. What does that tell us? What do we see there? We're seeing x in the exponent. That means we're dealing with a exponential function, and therefore that -1 is our horizontal asymptote. And then next, we are given g at x is equal to 1 over x plus 1. We are seeing x in the denominator now, which tells us that we are dealing with a what? with a hyperbolic function, and they haven't added anything there, so usually the value of q is not added or subtracted. What does that tell us? It tells us that the horizontal asymptote is what? Is 0. But instead they added something to the denominator, and that something will now give us a vertical asymptote. You will see it will give us the vertical asymptote. Okay, and then for 6.1, sketch the graphs of f and g on the same set of axes using the provided diagram sheet. Okay, we don't have it here, we'll just write it, we'll just draw it. Clearly indicates all intercept points with the x-axis and the y-axis, as well as any asymptotes. Okay, for 6.1, let's start by finding the asymptotes. So f at x is equal to 3 to the power of x minus 1. For that function, y is equal to -1 will be our horizontal asymptote. It's an exponential function, so we only have a horizontal asymptote. And then next, let's find the intercepts with the axis. For x intercept, let y equal to 0. So we're gonna have 0 is equal to 3 to the power of x minus 1. We take the 1 to the other side, we're gonna have 3 to the power of x is equal to 1. Therefore 3 to the power of x, let's solve for x. 3 to the power of 0 is the same as 1. We drop the bases, we're gonna be left with x is equal to 0. We use the laws of exponents for that. X is equal to 0. And then next, let's find the x is equal to 0, where y is equal to 0. That's the what you call this thing, the x-intercept, of which would be essentially the y-intercept, because the y-intercept is at x is equal to 0. So this is also y-intercept. So y-intercept is at what? 0 and 0. So they both share the intercept. So this function cuts the x and the y-axis at the origin, basically, where x is 0 and y is 0. What else do we need for the exponential? Basically, we have everything at this point. And then next, let's find the asymptotes for the graph of g. So g at x is equal to 1 over x plus 1. 1 over x plus 1. So y is equal to 0. Nothing is added there, which will be our horizontal asymptote. And then for the vertical asymptote, you must pay careful attention here. You don't just say x is equal to 1, but you say it what? You say x plus 1. You take the denominator as it is equal to 0. That will give us the vertical asymptote. Therefore, x is equal to -1. Is our what now? Is our vertical asymptote. Since this function has been shifted, towards what you call this thing, has been shifted 1 unit to the left. Therefore we're gonna have what now? An x-intercept. So we're gonna have an x-intercept, but not a y-intercept. Sorry, we're gonna have an x-intercept where y is equal to 0, because for the y-intercept where x is equal to 0, y-intercept, that's where we have the horizontal asymptote. at y is equal to 0. In fact, let's just calculate this thing. Oh, we're not gonna have an x-intercept at y is equal to 0. X-intercept, that's which way we have there. Yeah, at y is equal to 0. It's basically the x-axis, so we're not gonna have an x-intercept, because y is equal to 0 with all that equation would basically be just undefined, so we essentially gonna have a y-intercept here, a y-intercept. So for the y-intercept, we let x equal to 0, y is equal to 1 over 0 plus 1, therefore y is equal to 1. That would be the x, that would be the y-intercept, sorry. Okay, and then next, we have to sketch these two functions. Okay, let's just draw our axes, sets of axes. This is x, this is y. 1 2 3 4 5, 2 3 4 5, 1 2 3 4 5, 1 2 3 4 5. It's -1, -2, -3, -4, -5. 1 2 3 4 5, 1 2 3 4 5. We have a -1, -2, -3, -4, -5. Okay, let's start by sketching the exponential function. It has the horizontal asymptote at y is equal to -1. Y is equal to -1. That's the horizontal asymptote. Y is equal to -1 for the exponential function, and then it has the x and the y intercepts at the origin. Therefore, we can now sketch it. It's an exponential function. It's gonna be of that nature. Okay, and there you have it. And then next, let's sketch the hyperbolic function. What do we have? We have a vertical asymptote that x is equal to -1. Now we take a ruler at -1. At -1. That is where we have the vertical asymptote. That x is equal to -1 for the hyperbola. X is equal to -1. Do we have any intercepts? We have the y-intercept at what? At 1 here. And then the x-axis, where y is equal to 0, is the horizontal asymptote. So the function doesn't touch the x-axis. So this function will be of this nature. Yes, that's the one branch, and then the other branch will be like this. Remember that the horizontal asymptote there is for the, I should have just used different colors. In fact, for this one, let me also, it goes with the purple function, the exponential function, where y is equal to 0, and then the red one, it goes with the hyperbola, the green function, So we can label our function. We have an y-intercept there at 0 and 1, 0 and 1. We have 0 and 0 there at the origin. We have labeled the asymptotes. Okay, we can label our function. The green one is the function of g. It's g at x is equal to 1 over x plus 1. And then the purple one is the function of f, the exponential. F at x is equal to 3 to the power of x minus 1. And there you have it. This is how you'll go about sketching that function. Okay, and then using your graph, write down the coordinates of the point of intersection of the function of f and g. Coordinates of the point of intersection. Let's go ahead and see where our functions intersect. The functions intersect, I would like to believe, at 2 points there and there. That is where they intersect. So we know that our graph was not drawn to scale, so we can't just use the Cartesian plane. Instead, what are we gonna do? We're gonna use that method I was telling you about, of equating. We are also looking for the point of intersection where x is greater than 0. So we're only considering this one where x is greater than 0. This one to your right, to the right of the y-axis, and that is 6.2. Since our graph is not drawn to scale, we just use the other method where we say f at x is equal to g at x at the point of intersection. What is f at x? F at x is 3 to the power of x minus 1 is equal to, what is g at x? I wonder if will be, the other one is y over 1 over x plus 1. Then next, what do we do here? We solve for x. Okay, so I think I see why they said we must use the graphs, because the other x variable is at the exponent, and then the other x variable is at the denominator. But let's make an attempt to solve this one. Gonna be, I think it's a bit complicated to solve this one. Instead, let's just use the graphs. Because when we try to solve this equation, we're gonna have x plus 1 into 3 to the power of x minus 1 is equal to 1. Now you see what we have there. It's really complicated. We have x as the exponent there, and then we have x. We basically have two unknowns, of which makes sense because we have two variables. We have two values of x. But we are not interested in the one in this side. Let's just use the graphs to determine. This is what 6.2. So the x value is between 0 and 1, and the y value is between 0 and the y value is also between 0 and 1. Okay, so we can say we have to estimate here. We have to estimate, and in order to estimate, we're looking for the coordinates. It's gonna be, let's go with 1/2, which is 0.5, and then the other one we go with 0.7 because it's above 0.5, or even we can go, I think, with 0.5 again. Let's just, I think it will most likely be half and half. Let's just take half and half, 0.5 and 0.5. Yeah, because this one is not drawn to scale. Maybe if we're using the ones that they gave, the x's that they gave us, this was gonna come out a little bit more precise. Okay, what is the range of f, the exponential function? So the range of f for 6.2, so the 6.3, the y values, the function of f exists for all the y values that are above -1. So it's simple. This one, you guys want to say y is greater than -1. You can present it that way, or you can say y is the element from -1 round bracket, from -1 round bracket to +infinity round bracket. Okay, domain of G, the domain of G, the hyperbola now, 6.4, the domain of G, we can see that G does not only exist for all the x values except set x is equal to -1. So we're gonna say x is the element from -infinity to -1 union -1 to +infinity. That's one way. Or you can say x is the element of real numbers, but x is not equal to -1. That's another way of expressing that function. This is 6.4. Okay, that was the domain question, looking at the x values. Okay, and then 6.5, write down the equation of the asymptotes of G. Domain of G. What is G? G is the hyperbola equation of the asymptotes of G. That is 6.5. We've already calculated the equations of the asymptotes. Is x is equal to -1 and y is equal to 0. So 6.5, we've already determined x is equal to -1. That is your vertical asymptote, and y is equal to 0. That is your horizontal asymptote. Next, and then 6.6, determine the values of x where g at x, the function of g, is less or equal to 0, where x is less than -2, where x is less than -2. Okay, g at x is the hyperbola where x is less than -2, where x is less than -2, and we're looking for the values of x where g at x is less or equal to 0. So from essentially here at -2 going in that direction, the values are gonna be essentially where x is less than -2, because that is where g at x is less or equal to 0. So basically where x is less than -2, and that is your answer. That is your answer. Okay. Yeah, and this is how you will basically go about answering this question. I think it was the last part of this question paper from 2020. It was from Eastern Cape. It was written in Eastern Cape, this one. And I hope you guys learned something, and until we meet again, I wish you good luck and good studying.